Operationalization and why it's important. First, though, a company announcement. We're delighted to have closed a 2.7 million seed round, which is led by Amadeus Capital, leading UK deep tech fund. They've invested in companies like Improbable, 5AI, Graphcore, Prowler. They've been around for about 20 years, have a huge amount of experience. And Alex van Someren has joined the board. We also, within that round, co-investors included Global Brain. You'll meet Naoki today. They're a Japanese growth fund. They've invested in two UK-based companies. The other one is Geospot, based in Cambridge. And Naoki's actually just moved to London, and you'll see that's a great thing for AI and deep tech over here. And obviously Techstars we've been very close with since we're part of the Barclays Accelerator in 2016, where we learned a huge amount that actually really helped to shape the roadmap which we're on right now. So previously Seldon was more of a end-to-end machine learning platform that sort of spun out of a recommendation engine. What we've learned really is that the hard part of running machine learning models in sort of the real world is not the algorithms and model building, it's in serving those machine learning models and maintaining and scaling them in production. So after we were on the Barclays Accelerator, we decided to focus on deployment, so the sort of later stage of the sort of machine learning workflow or pipeline, and we went back to the drawing board and basically rebuilt our platform from the ground up, focusing on serving machine learning models using Kubeflow, which our CTO will talk more about. So a container-based solution that originally came out of Google and is now sort of the number one sort of cloud-native solution for running complex applications across clouds and on-prem. So since we released Seldon as an open source product, we've been really blown away by the traction it's received. So we see here 185,000 installs. Over the last 6 months, we've seen 40% month-on-month growth in active clusters, and the active nodes, which are actually sort of a proxy for the amount of workload within those clusters, is growing at a faster rate. Actually, there have been periods where we've seen kind of giant clusters switching on, and sometimes we don't, obviously, people will remove the anonymous sort of logging when they move into production. So there's I think a lot more large-scale clusters out there that we don't see as well. I took actually a look this morning, and this is the latest stats on GitHub. We've got 706 stars, 120 forks. So these are all companies that can contribute back to Seldon, or sort of closer to doing that. But actually, when we looked at the last 50 issues that we'd closed on GitHub, and these are things which have directly made their way into our product, I was actually blown away by this stat that out of the last 50 issues, 35 of those were from outside parties, not within Seldon. So that's 70% obviously of our closed issues, and that's really great. It shows the power of the community in building a better product. We've been collaborating with Kubeflow, which is Google's AI or machine learning toolkit for Kubernetes. It's become like a big sort of standard framework for that sort of end-to-end ML within that environment, and they're building an ecosystem of which Seldon sits as a component. We're also integrated into the IBM Fabric for Deep Learning, which was a spin-out of Watson. And then we're also integrating into some of the leading data science platforms for the enterprise. Example of some known users of Seldon Core. We're partnering with some of those as well, obviously. And if anyone wants to engage with us, the sort of first port of call is to connect with us on Slack. So we have an active Slack community with now 300 members, and we have very sort of active dialogue in there, and our team are there to answer any questions you may have. So diving back into ML Ops, we really are on this S-curve at the moment with or any technology is on an S-curve. Okay, so you have a sort of period of adoption, and then it sort of plateaus. Once you have sort of this critical mass of usage, but then the expectation with AI-based technologies is the S-curve effectively turns into a J-curve, and the organizations that have an ability to operationalize and leverage these models within the real world gain a significant advantage and are able to build huge scalable businesses. So the problem, though, is that machine learning only represents a very small part of the systems that are required to deploy machine learning in the real world. So this is from a paper that was created by Google, which tries to sort of symbolize or show the amount of code that goes into each of these supporting systems. And where we sit at Seldon is over here within the serving infrastructure and anything which is based around running models in production. So some examples there are resource management, analysis tools, serving infrastructure, monitoring. So what's also important is bringing together the sort of different constituents of a machine learning project. So it's not just data scientists. It critically starts with solving a business problem, having business stakeholders identify what KPIs they're looking to improve. And then once the data scientists have built the model, it's important that they can coordinate with the DevOps teams in order to actually run them in production. And so within the technical team, within the DevOps and data science team, these roles around DevOps and data science have completely different skill sets. So they really taught different languages, and they're often siloed into separate teams. So you've got data scientists who are building models, and then sort of tuning them and improving them over time. Data engineers who are building out the data pipeline, and then DevOps in charge of productionization. And these teams are often in different departments, physically separated, and the systems are not in place for them to have a good feedback loop. So often a model gets chucked over the wall to the DevOps team, and they may not have a sort of closed feedback loop on the performance and the KPIs that model has produced. Or even critically, if the model starts going downhill and delivering results that are not expected, that can negatively impact the business, that doesn't get caught until it's too late. So this role of an ML engineer is emerging. It very much is a unicorn role that requires an understanding of both disciplines, and very hard to find. And that's really what we're solving at Seldon, is to enable the data scientists to have more DevOps capabilities and the DevOps to have more data science sort of understanding. And that's what we found at Seldon, is finding the people who have those skill sets is a challenge. And okay, cool. So most businesses, obviously, as I said, start with business understanding. This is some great, comes from a great paper report that Gartner produced recently. Independently of Seldon, then we realized they basically, everything we've done, everything we're doing is in line with what they're seeing in the market. So you have the kind of early stages of model development, so data discovery, data wrangling, analysis, model validation. And then once you have your model that you want to put into production, it gets passed into your operationalization cycle, where you hope to get some kind of actionable insight, whether that be something we can integrate into a business process or some form of decision making. And so you have this sort of model release cycle, testing, validation, and then the output should be some KPI, influence on the business, that you can measure, and then what should typically happen then is that you can report that back into business understanding and then sort of rinse and repeat on those two cycles. So there is actually a third cycle, which really is our focus at Seldon, which is around the sort of activation of models. So not just the operationalization, but ensuring that those models can run within your application within a strong governance framework. So what we have here is things like model explanation, bias detection, checking whether the model is going out of date in terms of is no longer aligned with the data that's been fed into it. And this sort of model governance and model management cycle also lives sort of independently from the operationalization cycle, the sort of deployment. So the 3 recommendations we see here, I'm just reading it directly from this paper because it wasn't written by us and these guys are obviously very authoritative. The recommendations for ML ops. Obviously the context is there's a huge amount of technical debt associated with running ML in production in the current, in the status quo. And the 3 recommendations, first is to start early and address the KPIs that need to be, that you need to actually influence to establish the success of a project. Secondly, you make sure you have a very sort of strong operationalization process, and you're able to track the behavior and the performance of those models in production. And then those 2 pieces will enable you to start solving a business problem. But if you miss out the final step of having a strong governance framework, then you're saving potentially catastrophic issues for later down the line. There are other organizations that we're engaging with and supporting who are also looking at these challenges. One is the Institute for Ethical AI and Machine Learning. So Seldon's an advisor to the board there. They've identified a set of principles for responsible machine learning. I won't go into all of them right now in the interest of time, but includes things like bias evaluation, explainability by design, which we'll be talking a lot more about today. You can check them out at ethical.institute, and they've also produced a fantastic procurement framework that organizations can use to procure machine learning and ML ops infrastructure by analyzing how it sort of meets these ethical requirements. This is an example of the kind of pipelines that they've put in place to explain this. So you have your model development pipeline that sits independently from your model serving pipeline, and these are connected through kind of an ops framework that will bring, or ops processes that enable things like model and data versioning and orchestration. So that's really important so that you have reproducibility. So within your ML pipeline, so should you want to go back in time and ask why a certain decision was made, you can rerun the model using the same sort of version of the model and the data that was produced at the time and deliver a response, whether that be to the customer or to a regulator. And orchestration, because actually there are many models that need to be brought together for most advanced applications. And it's not just models, but it's also the components that connect them together. So things like having a testing framework driven by a multi-arm bandit, or a concept drift or an outlier detection, that all needs to be sort of connected in one place. And that's something which we've been building at Seldon. As I mentioned, we are focusing on the late stage of the ML pipeline. This is something that was produced by Kubeflow initially, and the Kubeflow fabric for deep learning sits more broadly here. Kubeflow, as I mentioned earlier, have integrated Seldon because of this support for wrapping up, packaging and deploying models created in multiple frameworks, and the inference graph that we've created to orchestrate those machine learning models. And we're also collaborating with Intel on various things, but one of them is an example of how Seldon integrates with their OpenVINO framework, which is a deep learning computer vision framework. And there's an example on the Intel blog here, which you can read, that gives a deeper sort of demo of how you can deploy Intel OpenVINO models, also how you can deploy models on the Intel nGraph, which is the inference engine. So that's really exciting for us. It's not just having an inference graph that allows you to connect and deploy multiple models, but you can deploy within the same deployment multiple different inference engines. So you could be testing out whether one model runs the same model or the same use case, have one model running on NVIDIA GPUs and the other model running on Intel Xeon CPUs. So that could be extended as more and more hardware becomes available, which is really the big battleground that we're seeing emerging. So companies like GraphCore and TPUs from Google, Seldon will support all of that within one framework. So what we're focusing on this year, this is why we raised the funding. We're building out an enterprise management interface that sort of senior levels of management all the way through to the data scientists can use to manage deployments across multiple clusters, across multiple clouds, on-prem, ensure that there's a team environment where it's not just a single data scientist issuing commands and using systems which really they only know how to control. It enables simplified workflows connected to approvals and analysis of the audit trail. And you can actually design these deployments within this interface. So we're focusing on that this year. We're hoping to get this released by the summer. And you can sign up to the beta here. And here's an example of some of the features that will be part of Seldon Deploy, some of which actually will also be part of Seldon Core, but we'll be kind of implementing sort of a more of an easier to use interface within Deploy. So examples being the explanations, which we'll talk more about, outlier detection, which actually we have a comprehensive outlier detection suite within Seldon Core, bias detection, and then reproducibility.